Hello, everyone. A very good morning. Dear author and invited guests, welcome to Technical Session 9D. Myself, Richa Shah, and this session will be moderated by me. On behalf of the Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the ninth International Conference on Information and Communication Technology for Intelligent Systems, that is ICTIS 2025, held in Bangkok, Thailand. The ninth edition of this conference is being organized in a hybrid mode. The physical event was held yesterday in Bangkok, and the virtual event is being held through Zoom on the 5th and 6th of April 2025. I hope you will all enjoy the knowledgeable and interactive sessions through the day. So, in this session, we will have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, you can write it to me in the chat box. So before we start with the session, I would like to introduce you all to our session chair for today. Sohil Rana sir is a senior lecturer and head of Department of Electrical and Electronic Engineering at Northern University of Business Technology, Bangladesh. Sir has published more than 44 articles in peer-reviewed journals, book chapters, and international conferences. Welcome to the session, sir. Our second session chair for today is Sachin Gupta, sir. Sir is a passionate technology enthusiast and educator with teaching and administration experience for over 20 years. Um, Sir is Dean Research and Innovation at Maharaja Agrasen Institute of Technology, Delhi, India. Sir, welcome to the conference.
Thank you so much.
So now we'll be starting with the presentations. I'd like to call Mr. Yash Gawale for the paper titled A Pipeline of Weak Supervision for Misinformation Detection. So please, can you start with your presentation?
Hello, am I audible?
Yes, sir.
My screen is visible, right? Hello.
Yeah, it's visible.
Okay, good afternoon, everyone. My name is Yash, and I'm here on behalf of Priyansh Gupta, Vinay Paled, and our mentor, Bhaskar Jyotidas. We are from PS University, India, and today we'll be discussing our paper title, A Pipeline of Weak Supervision for Misinformation Detection. So, as we know, in today's world of social media, misinformation is a very big problem that can mislead people, disrupt the trust in institutions, and cause social unrest. So, by improving how we detect
Sir,
misinformation,
are you
we aim.
speaking because you're not audible?
Hello,
He's audible.
I am able to hear
am I
them.
audible?
Yeah, please speak. Continue.
Yeah, so by improving how we detect misinformation, our aim is to protect the public dialogue and ensure the decisions are based on accurate information. So let's move ahead to the challenges of misinformation detection. So as we know, misinformation spreads quickly and widely, making it difficult to contain. And also, misinformation is dynamic in nature. That means it contains satire, irony, interdisciplinary content. So which is difficult to incorporate in static detection models. And why does traditional method fall short? So traditional methods fall short is because they mainly depend on human annotated data. They have poor cross-domain generalization and they lack standardized credibility signals. Also, they have some scalability issues.
But you're not
So
audible.
is it not audible?
It is audible.
Okay, so as discussed earlier, misinformation is dynamic in nature. And traditional methods fall short as they have manual fact checking and they contain sheer volume and complexity of data. Our method is we have leveraged LLMs with weak supervision to form a pipeline of real-time misinformation detection. So we have employed a model called Llama 2 along with Snorkel to generate weak labels that efficiently automates the data labeling process. So we have leveraged LLMs. So why have we used LLMs? So LLMs have superior ability to understand and process complex human language and also complex language nuisance, which accurately detects the misinformation in real time. So our Llama 2 is used to extract the credibility signal, which will be a basis for training data labeling. So as you can see, this is the template of our Llama. It contains three components: introduction, input, and response. So suppose we have an article and we uh, give an input like, does this article contain clickbait? So it gives a response in 0 and 1, like does it contains clickbait, yes or no? Okay, so in our research, we have used 19 credibility signals. So here credibility signals are critical indicators that helps us to evaluate the trustworthiness of our content. So some of them are bias, correctness, and linguistic features. So methodology. So our first step is data collection. So we've utilized fake news CMT dataset that is a mixture of both misinformation as well as non-misinformation articles. And we have used BuzzFeed and PolitiFact dataset for broad testing. So we're doing cross-domain testing. So we've used a dataset of different domains, that is political dataset for testing purpose. Our next step is LLMs. So we are using Llama 2 model to extract key credibility signals like source credibility and emotional valence from articles. The next step is we're using labeling functions. So from the extracted credibility signal, we're generating weak labels. So the labeling functions, we have created our own, we have set up some labeling functions that uh, generates weak labels. So for example, let's say our article has high emotional valence and low source reliability. So then it labels that as misinformation. Once all the weak labels are generated, the snorkeling model aggregates all of this output into one, and then we train the model on that. Also, we have trained the model on for strong supervision, like various models like SVM, uh, random forest, just to compare how our weak supervision model is performing against strong supervision model. So we have done some statistical testing using Pearson chi-square test that is used to confirm the significance of the credibility signals. We have used the threshold of 0.05. So in brief, what we're doing is we're using LLM to extract credibility signals. Then we are using the labeling function to generate weak labels for the extracted credibility signals, which is then using Snorkel. We are aggregating all of that into one, and then we train the model on that, and then we are comparing with strong supervision. Now let's look at the results and comparison. So we have done it in two scenarios: one in-domain and cross-domain. So in-domain, we have performed in-domain comparison with Roberta. So Roberta is a state-of-art misinformation detection model. So and Llama FT also we have compared it with that. So our model outperforms Llama FT and it gives about 80% of accuracy of Roberta. But in cross-domain, when we test it for a data set of different domain, our model outperforms that of Roberta by 0.22 point and also it outperforms Llama FT obviously. Next, we have compared our weak supervision model with other strong supervision models. Now, our weak supervision model on our trained data set, it gave an accuracy of 78%, and on random forest, it gave 84%, and so on. But when we tested for some cross-domain data set, it gave an accuracy of 78%, which it retained the accuracy, as you can see. And random forest, there's a significant drop in the data set, I mean, in the accuracy when we do it for cross-domain testing. So the conclusion is what we're trying to do is we're trying to minimize the need of extensive manual data labeling. So we're incorporating LLM plus weak supervision that not only improves the accuracy but also automates the manual labeling of, automates the labeling process. So it's also cost effective since it reduces the reliance on heavy label data. Right now, we have done it only for English language, but our future directions are incorporating multilingual support to effectively detect and analyze the misinformation. So that's it. Any questions, we'll be happy to answer.
Uh, may I? Yes.
Yeah, yeah.
Yes, how credible is LLM? I mean, you say credibility of misinformation. You are creating parameters against your model, but how credible is a LLM?
LLM is it's already pre-trained on a large data set, corpus of data set,
Uh,
like 70, and it's
I,
also trained on 70 billion parameters.
I
So we
understand
have,
that.
yeah,
My question is, how do you ascertain the credibility of a LLM itself?
Hello, sir. I'm Vinay. I'm also one of the contributing authors.
Yep.
Sir, to answer your question, the LLM, we use LLM with the credibility signals with a specific prompt design, sir. So rather than actually utilizing the LLM's pre-trained knowledge base, with the help of that alpaca prompt format, it only gives us the specific answer based on, um, for example, like we just don't ask it what's the variance, what is the credibility of the source or something like that. We ask it to generate decisions based on some kind of quotes, like some kind of suppose some online resource or something like that. So we try to do cross verification in that. The prompt,
Uh,
that alpaca prompt, helps us to use the LLMs in a very defined manner. It is not
okay, correct,
open-ended, sir.
correct. What is the cutoff? What is the cutoff for Llama 2?
Cut off in the sense that, sorry.
Cutoff in the sense, what is the knowledge cutoff? What was the last uh, knowledge cutoff date for Llama 2?
Sorry, sir, I'm not aware of that.
Okay, no worries. That means whatever model you are using, that should be able to browse the web along, in addition to having the large language model.
Yes, sir, the prompts are designed in a way where they generate the answers specifically based on some kind of credibility.
All right, all right. Okay, thank you so much. Great presentation.
thank you, sir. Any other questions?
No questions, I guess.
Thank you.
Thank you for the
Thank you.
presentation, sir. Um, Moving on next, I'd like to call Mr. Vasant Kumar for the paper titled Integrating Building Information Modeling (BIM) in the Construction Projects, a study to increase the efficiency of construction projects. So, can you please start with your presentation?
Yep. Can you see my screen now?
Yes, sir.
So, hi everyone. My name is Vasanta Kumar. So today I'll be presenting the topic integrating building information modeling in construction projects, which is a study to increase the efficiency of construction projects. So this presentation will explore how BIM will increase the overall project efficiency, especially reducing the cost overrun and the delays in the construction projects. So, as you know, BIM has become a crucial part in the construction industry now. It is a process. It's an important process for all the projects, and it's an essential tool for project stakeholders in the construction industry nowadays. And some projects still fail due to poor BIM awareness. Even though they implement BIM, some projects fail. So that is an area of concern regarding BIM. And this research focus will be to investigate BIM's role in reducing delays and cost overruns, and also to increase the overall efficiency of the project. So there are various literatures available for the BIM field. So they all contributed in, exploring about cost reduction, time savings, and the waste reduction in the sense of sustainability projects and energy efficiency. So there are quite a few barriers to BIM implementation as well in the construction industry. I've I've noted a few of them here. The first one is lack of skills. So major concern is the lack of skills across the industry. So a lot of new BIM software and tools are uh, coming in today's new technology. So lack of skills is a major concern today. And another thing is high costs involved in the software and also involved in the training expenses. So whenever we implement a new software or a tool in a new project, we need to train all the employees involved in the project. So it costs too high. And the third important barrier is the resistance to change, especially among the older employees. So they are a bit hesitant to change to new tools that are getting updated whenever the new year comes. So first one is communication and stakeholder collaboration. So the collaboration tools include Econex, Autodesk 360. These all will help all the project participants to come at a single place to collaborate and communicate effectively on a project. And these also help in getting real-time updates from the projects like construction progress, project tracking, and design changes, cost, everything. And the third one is satisfaction. So these tools greatly promotes stakeholder satisfaction because of the better understanding of project status. So there are few research gaps as well. The first one is BIM's impact beyond execution phase. So BIM is being implemented, in mostly design phases and the execution phases, and it is yet to explore more in the after execution phase. And it should also be, integrated with other platforms like AI, IoT, AR, VR, so that we can explore a lot of ways to implement BIM in construction projects. And the third thing is cross-disciplinary collaboration and education towards BIM field. So the research question is, how does incorporating building information modeling in construction project increase the project's overall efficiency, especially cost overruns and project delays? So the main objective of this research is to showcase BIM's importance in today's industry and how it actually increases the project efficiency. So this research will also answer the question, how does BIM increase overall project efficiency, and it will be focusing on cost overruns, project delays, collaboration, communication. So methodology is we have concentrated both on quantitative and qualitative research methods, and uh, got the data from different sources such as industry reports, academic papers, case studies, and few data analysis as well. So we have done the data collection from from the following areas like industry reports, annual reports from industry leaders like Autodesk, McKinsey and Company, Bentley, etc., and few of the academic papers as well, and the case studies on projects that was there before BIM implementation and after BIM implementation. So finally, let me jump into the results and conclusions. So the factors contributing to delays and cost overruns, as you could see in this table, 25% of time delays and 15% of cost overruns are caused by inefficient communication, and 40% of project delays and 30% of cost overruns are due to poor planning of the project. There are other reasons as well, like ineffective resource allocation and design errors and changes in the later stage of the projects. So these all causes delays and cost overruns. So how BIM impacts on communication is explained in this slide. Like as you could see in this bar chart, in the initial stage, you could see only 60% communication efficiency is there. But when BIM is implemented, you could see more than 80% of efficiency. And another example is in the construction coordination, around 80% efficiency is seen in the BIM implementation, whereas only 60 less than 60% is seen in traditional projects. So we could also see that 30% increased collaboration efficiency is seen when compared to the traditional CAD methods, and 85% of stakeholder satisfaction is seen when compared to traditional methods, which is only 55%. So these are the barriers, as I mentioned earlier. So about 40% of small and medium enterprises struggle with BIM adoption costs because it involves high initial cost and for the training as well. And 35% of companies lack BIM proficient employees. They are still managing their projects with only traditional CAD methods. And as I mentioned earlier, 25% of respondents were reluctant to adopt BIM workflow because they don't want to spend extra time to learn a new thing. Uh, so here we could see the difference between traditional projects and BIM integrated projects. Like stakeholder satisfaction is very high, more than 80% when BIM is implemented, and cost overrun and reduction in delays is seen is pretty good in BIM integrated projects than the traditional projects. So we have also analyzed some case studies which are BIM versus non-BIM projects. For example, Kuwait's project and Cairo Public School project did not have any BIM in their projects. So we could see a lot of cost
Uh,
overrun, time
Excuse
overrun,
me,
and
sir.
communication satisfaction is also very less. Sorry.
Sorry to interrupt you. Around 9 minutes are over. Can you please wrap up?
Yeah, I'm completing last two slides. Thank you. So, but we could see that in BIM implemented adopted projects like Malaysian government school and KTech school project, a lot of improvement is seen. So these are just regression analysis to show the results of our analysis. Like when BIM adoption is more than 80%, you could see 30 to 44% reduction of cost overrun. So that's the result. And similarly, time overrun, 80% of BIM adoption reduces time delay from 30% to just 5%. It's quite a great result. And communication satisfaction is also very high whenever BIM is adopted because all the stakeholders come to the same place. So these are the key takeaways, like BIM significantly reduces cost overruns and time delays and greatly enhances the communication. And we should also take into note about this high cost and skill gaps, which remains key barriers to BIM adoption. So future research can be in these areas, like explore BIM 60 BIM for facility management and study BIM with AI, IoT, and AR. And you can also develop cross-disciplinary education during the BIM training programs. Yeah. So these are the conclusions and recommendations. So we can also start developing affordable BIM solutions and invest a lot in training so that we can have a better future with good construction projects with reducing a lot of waste in the construction projects. Thank you.
Vasant just asked one question, one single question.
Yeah.
You prepared a regression model where you are showing that 1% increase in BIM increases 33% satisfaction or reduction in cost. Correct, I understand that. How many data points are you basing that conclusion on?
Sorry, come again. How many?
How many data points did you take for that regression line projection when you made that graph?
We analyzed four important projects, and
If you are analyzing four projects with four data points and you are creating a regression line,
yep.
do you think would it be possible that there may be more data points which might indicate otherwise?
Uh, I don't think so because I come from a construction background and I work in the industry. The reason for analyzing only four projects is time constraint. And another thing is we clearly understood because all these four projects are going in the same direction. So we analyzed also a lot of in a lot of perspectives in different stages of the projects. So yeah.
Yeah, yeah. I'm not challenging that your expertise. I'm just saying that when it comes to data, it's not a
Yeah.
very good indicator when you could simply
Yes,
say
yes.
with your expertise that would be good, but portraying a
Yes, yes,
graph
I
which
agree with
says
that.
that is a hard challenge.
Yes, yes, I agree with that. Yeah. There
Yeah.
should be more
Thank,
data points. That I agree with that. Yeah.
all right. Thank you so much.
Thank you. Thank you so much for your question. Is there any other question?
Thank you so much for the presentation, sir.
Thank you.
Moving on next, I'd like to call Mr. Krishna Somalaram for the paper titled Aura Vox, Redefining Communication with End-to-End High-Fidelity Visual-to-Speech Synthesis Powered by Transfer Learning. Sir, can you please start with your presentation?
Yeah, am I audible? Hello, am I audible? Am I audible?
Yes, sir.
Yes, sir.
Thank you. Is my screen visible now? Yeah. So, hello everyone. Today we'll be presenting my paper, which is AuraVox Redefining Communication with End-to-End High-Fidelity Visual-to-Speech Synthesis Powered by Transfer Learning. My name is Krishna and I'm from PES University. These are all the team members who have contributed to the project as well. So this is the content of the presentation that I'll be presenting today. Introduction, summary of prior research, objectives, proposed methodology, a little bit of implementation details, as well as result and analysis with conclusion. So the main focus behind the project was to ensure that we could give a voice to people who are either non-verbal individuals or who have lost speech. The main focus was always, as we know, that communication, whether it is verbal cues or facial cues, hold immense importance in human interaction. And we thought of bridging this gap by using lip reading technology along with personalized voice synthesis to ensure that we can give a voice to the people who either have issues with their vocal cords or any sort of ALS disorder. By merging these technologies, the aim is to enhance accessibility for speech disability and enrich human-machine interactions. So this is just 4 base papers that I'll be presenting right now, and what are the main learnings we got from each one. The first paper talks about the challenges in training TTS models for new speakers with limited but high-quality speech data. The second paper talks about the various models and the comparison between these models. Based off this paper, we were able to understand that Tachytron 2 was probably the best text-to-speech synthesis model we should go for. The third paper talks about LipNet, which was the first model that maps sequences of image frames from speaker's mouth to the entire sentences. The fourth paper demonstrates that the models trained on some smaller pre-trained data sets achieved comparable quality to those trained from larger data sets from scratch. So the main objectives were to integrate 3 modalities, which is text, audio, and video. We were able to generate a personalized voice synthesis, implement and fine-tune models like Tachytron 2 and Hi-Fi GAN, train and evaluate models using diverse datasets like LJ dataset, and we also created our own datasets with 3 of the authors, which is over 45 minutes long of 750 utterances, different utterances. We integrated an end-to-end TTS model to the novel architecture of LibRead. So the main first step in the methodology is to involves a collection of data sets. The LJ dataset contains almost 13,100 audio clips and transcripts, which serves as a primary source of speech data. It provides approximately around 24 hours of single speaker speech. In addition to that, as I mentioned, custom dataset was also created, which had a mono audio of 22,050 hertz from 3 authors, and they were trained. The second step involves the audio pre-processing steps. As mentioned, to prepare the data for modeling and training, we had to ensure that all the audio files had a uniform 22,050 hertz sample rate. We had to remove any silences which are longer than 0.5 seconds and also apply text normalization of UTF-8 and end of sentence tokens. The third step, which was the core of the methodology, is the training of Tachytron 2, which is a sequence-to-sequence model that utilizes attention mechanisms to convert text into MEL spectrograms. These spectrograms represent the audio features, which were then used for waveform generation. To further optimize the model, transfer learning is employed by fine-tuning a pre-trained Tachytron 2 model on the custom dataset. This reduces the training time required and enhances the model's efficiency by leveraging previous knowledge. Another part of the main methodology was to train the vocoder, which is specifically the hi-fi GAN, which we use. It is trained to convert the MEL spectrograms generated by Tachytron 2 into high-quality, natural-sounding waveforms. Audio post-processing techniques like spectral gating, short Fourier transform, and adaptive gain control were also used to further enhance the quality and clarity. Lip reading integration is also introduced to improve the model's ability to synthesize speech from visual cues. So we had to use a grid corpus dataset, which was a dataset which was already present, which had two authors, two speakers along with their video samples, which we based for our lip reading. Another important part was the resampling, as I mentioned, which is 22,050 hertz. We removed any silences worth 0.5 seconds. Noise reduction, because we had to implement a band pass filter in order to target frequencies between 300 and 3,000 hertz, because that is where usually the range of human speech lies. We had to normalize text and also remove any unwanted characters from the transcripts along with lower casing as well. And we added an end of sentence token to each transcript to ensure that this was the end of the statement. Basically the most important feature of Tachytron 2 is that it maps character embeddings to the MEL spectrograms, which are used for intermediate representation for generating speech. The base model for fine-tuning is the pre-trained Tachytron model, which is already available on NVIDIA or other open source repositories. We chose this pre-trained model because it already learned to map phonetic information to MEL spectrograms, significantly reducing the required training time on the custom dataset. So as mentioned above, we had a unique data set of 3 individuals. NVIDIA's Tachytron 2 model was used. We leveraged hi-fi GAN to synthesize high-quality audio. We refined and prepared the custom data set for efficient audio synthesis, generated MEL spectrograms from the custom data set using Tachytron 2 for advanced audio processing. We generated high-quality MEL spectrograms. We used hi-fi GAN for realistic high-fidelity audio generation, incorporated lip reading for synchronized visual and audio output, applied spectral gating for noise reduction and cleaner speech, used short-term Fourier transform for improved signal reconstruction and clarity. So these are the results and analysis that we had gained. As you can see, this is the decoder and encoder timestamp, and the attention alignment map shows that a strong diagonal indicates that the model is correctly aligning encoder and decoder timestamps. We compared our iterations with that of the first author, and with his 27,000 iterations, he got a 0.22 training loss and 0.21 validation loss. But ours got with 20,000 iterations, we had 0.13 and 0.07 validation loss. So as you can see, the MEL spectrogram, this is what the MEL spectrogram prediction looks like. It shows a clear and consistent pattern, which indicates that it is generating high quality audio features. This is the training and validation loss. So this demonstrates that a steady decline, suggesting that the model is learning and effectively and improving over time. So this is an audio post-processing technique we use, which is spectral gating. It's an audio signal processing technique used to reduce background noise while preserving the clarity of the sound. This is the audio post-processing results. So this is the initial or original output. As you can see, there are a lot of inconsistencies and gaps in the audio. But after masking and using STFT, we were able to mask them. But at the same time, we also preserved the primary source of the audio features. Similarly, in the STFT, as you can see, there were a lot of distortions, but the distortions have remained, but the quality and the primary source has been sustained. So this is my voice, which was trained for just 15 minutes of training. We got this audio sample. I hope you can hear it. Yeah. We are delighted to present our progress today. So this is just my voice at 15 minutes of training, and we were able to get this particular transcript read out. We are delighted. So comparison with existing models, Aurovox lip reading, which is our model, had a lower character error rate, along with a lower word error rate compared to the other models which were there. So this shows the performance of the lip reading model. So as you can see, initially for lip read, what we do is we take the video sample, we grayscale it, and we focus on the lips to generate a predicted text. So as you can see, there are some inconsistencies, but as the data set gets bigger, the model learns more effectively. And these small nuances, whether it's a letter which sounds the same or it speaking in terms of lip movement, it's similar, there is some errors, but we are working on that. So on conclusions and future scope, we effectively translate lip movements into speech, improving communication for speech impaired individuals. We process lip reading in 3 to 4 seconds and speech generation in 2 seconds with reduced latency over time. We used Kalman filtering and spectral gating to enhance the speech clarity in challenging environments. Future improvements is to expand to multiple languages, improving generalization to unseen speakers, and refining occlusion handling. These are the references. Thank you. Is there any questions?
Excellent presentation, Krishna.
Thank you.
There is just one thing, that is it feasible that from place to place the accents change and the model will be trained for a specific accent?
So that is something we are working on, because right now, because of the low availability of data sets, we have experimented with our own voices, and it was giving a pretty high quality speech, as you heard. But I think if we refine the model a little more and if diversify the data sets, which is a future aim of ours, we will try to. We also try to
Yeah,
languages, but due to computational requirements, we were not able to have it. We didn't have the RTX this thing, so we couldn't do it.
It would be good. You can use Notebook LM to generate 8 different voices, maybe the AI Studio at Google for many more. So you can create synthetic data sets, and that would be a very good contribution. In fact, several people would try to use that data set once you are done with that.
That is also one thing we're looking for.
Yeah. Thank you so much.
Thank you, sir. Is there any other questions?
Thank you for the presentation, sir. So moving on next, I'd like to call Poonam ma'am for the paper titled Design and Implementation of a Hybrid Decision Support System for Mental Health Prediction, Recommending Intervention and Mental Stress Evaluation using Machine Learning and HDSS classifier in the COVID-19 dataset. Ma'am, can you please start with the presentation?
Good afternoon, everyone. Just let me share my screen. Okay, is it visible to all of you?
Yes, it is visible.
Thank you.
Yeah, sure.
Okay, good afternoon, everyone. So today I'll presenting our research on a hybrid decision support system for mental health prediction, recommending interventions and the mental stress evaluation using the machine learning and the SDSS classifier on the COVID-19 datasets. So these are the table of contents which I'm going to cover. Like we will start with the introduction followed by the literature review, and then there are some
Can you please put it in presentation mode?
yeah, sure, sir. So it's an introduction. The COVID, as we all know, that COVID-19 pandemic led to a global mental health crisis, especially due to the shortage of a mental health professionals. As you can, for instance, we have only 0.5 psychiatrists per 100,000 people in some countries. So reports from WHO confirm a surge in stress, anxiety, and depression worldwide. Uh, second, let me show this as well. The psychological impact of COVID-19 before the COVID-19 was this, and after the COVID-19, it drastically increased. As if we talk about the individuals, there are a lot of stress, as they don't want to discuss with anyone, and they doesn't have proper solution. So we can say the psychological impact of COVID-19 increased the urgency for a scalable mental health solution, for which the AI and the machine learning provide a promising path for early diagnosis and the automated intervention, which is the primary aim of our proposed HDSS algorithm. So, in the literature survey, we reviewed the articles from like IEEE, Scopus, and Google Scholar. A structure four-step filtering we have processed on all the papers. Like we have searched for the articles, then we do the article screening and find the eligible article selections for we considered for our research, and then we finally included some articles which are of culture, and then we just started our work. So, what the knowledge gap we have identified, despite all the significant research, existing the systems typically focus only on either prediction or the classification. Very few integrate a complete support cycle like prediction, severity, evaluation, and intervention. So there is a critical gap that SDSS aims to bridge. What's the scope of the study? Basically, our study encompasses the development of a complete AI-powered mental health solution that starts from the stress prediction to classification and finally intervention, the recommendation, all within the one hybrid system. So this is the methodology used. The proposed methodology involves the two major components. The first one is the SPSS model, and the second one is a DRM model.
Is
SPSS
your
model,
screen frozen? Excuse
sir,
me.
no,
Uh,
no, sir.
we are still on the graph, I believe. Or please correct me if I'm wrong.
Uh, just check it again.
Yeah, yeah, sure. Now it is moving.
Okay. And now, is it moving?
No, no.
Okay, I think slideshow, you can't see the slideshow. So, okay, so this is the methodology. This involves majorly two components. The first is the SPSS model, and the second one is a DRM model. SPSS model is the stress prediction and support system, and DR is the decision recommender system. In the SPSS model, uh, this is basically a model which is responsible for analyzing the user inputs and then predict their stress level using a trained classifier. So based on this classification, the data is passed on the next module. Let me show you in the picture. So the train class the in sorry this model just analyze the user inputs and then predict the stress level using a trained classifier. So based on the classification, the data is passed on the next module for the personalized recommendation. Next is the DRA model. Just one more thing I have to include in this, the SPSS. Yeah, these are the key steps. And so first we have take the data sets. We used a COVID-19 related data set that captures the variables like the stress, anxiety, depression, and daily habits. And this data was collected using the online surveys and serves as a strong base for the data pre-processing. And then we have do the feature selection. So to ensure the best performance, we applied some feature selection techniques to identify the most relevant variables. So irrelevant or noisy data was removed at this step. And then there is a mental health classification in which we have used the hybrid classification of the decision tree, KNN, and the ADA boost. So the output indicates whether the user is under low, moderate, and or high stress. These after applying these algorithms, we get the some outputs which indicate whether the stress is under the category of low, moderate, or high. Next is the DRA model. So the DRA model or decision recommender aid takes the stress level which was predicted by the previous model and maps it to the suitable mental health intervention. It acts as a decision making layer in the HDSS. Let me explain this algorithm as well. So first of all, this algorithm defines the flow for generating recommendation, and it includes the mapping stress severity to its risk zones, like querying a knowledge base and returning the relevant treatment strategies, ranging from like counseling tips to the emergency supports. Then we have the knowledge database. This knowledge database contains the categorized intervention strategies that matched with the specific mental health profiles. It is constantly updatable and serves as the foundation for the personalized support recommendation. Next, we have the statistical analysis, in which we perform some risk analysis, probability estimation, and then compute the severity score. And then we have the recommendation model. This system provides the personalized mental health recommendations. So these may include the self-care tips, like counseling links, or escalation to clinical intervention. That's completely dependent on the severity and the probability levels. So these are the result analysis we have performed. The HTS
Excuse me,
system
ma'am.
was tested
Sorry to
for
interrupt.
accuracy, for precision, for recall, and for
Excuse me, ma'am.
score. Yeah.
Sorry to interrupt. Around 9 minutes are over.
Just
Can you please
there's
wrap
only
up?
one more slides left. Okay. So
Okay.
these are the previous algorithm, and this is was the proposed algorithm, and this result is calculated and then it compared with the previous one. So if I want to conclude, so I will say our hybrid system effectively addresses the mental health prediction and intervention. It also can serve as a scalable solution in both pandemic and non-pandemic context where the mental health resources are limited. So for the future direction, I would like to say, like, we aim to expand our system for the real-time application and integrate it with the wearable health data and improve the adaptability of the model using the reinforcement learning for even more personalized care. So these are the references, and any suggestions you have?
Can we understand what was the way you applied recommendation?
What way means, can you explain it?
I mean, you have your complete presentation. I understood it. Thank you so much for it. I just need to understand how did you, or what were the recommendations from the model, and how did you train your model for recommending?
Actually, we just take the input from the SPSS model, and and in the SPSS model we have some low stress, moderate stress, and the high stress. And on the we categorize all the stress in some parameters like 0 to 5 we have the low stress, 7 to 15 we have the moderate stress, and then 16 to 21 we have the high stress. And then we perform some risk analysis and the severity computations, like if we have a low score, then there is a low risk, and if it's the high score, there's a high risk. So then we have mapped them and then just take the query the knowledge base.
Okay, it was more like predictions instead of recommendation, if I'm not wrong.
It's predicting, and then it's recommending. If you have the stress, then you have to go to the clinical. You have to take the clinical.
Okay, okay. The recommendations are basically that based on the score, the
Yeah.
system will
Yes.
recommend something to you.
Yes. Yes.
All
Yes.
right, got
Yes.
it. Got
Okay.
it. Thank you.
Okay. Thank you so
Thank you so
much.
much.
Thank you for your presentation, ma'am.
Thank you.
Moving on next. 1 second. I'd like to call Mr. Kedlego, sir, for the paper titled State of Art in Human Machine Intelligence in Manufacturing System with Augmented Reality, a Smart Manufacturing Perspective. So, can you please start with your presentation?
Good morning. Am I audible?
Yes, sir.
Yeah.
Can you see my screen?
Yeah, sure.
Yes, we can see.
Okay. Good day, everyone. My name is Katleho Mowoje, and the title of the review study is State of the Art in Human-Machine Intelligence in Manufacturing Systems with Augmented Reality, a Smart Manufacturing Perspective. This is the table of contents of the presentation. Augmented reality isn't new, but its purpose is changing. For years, it's been seen as the automation tool, but now it's becoming a bridge, linking human intuition with digital precision. Industry 5 doesn't just want smarter systems, it wants systems that can collaborate with people. That's what this presentation explores, how AR is being used today and how we're building forward from there. Background. We reviewed a wide range of sources, and of the ones we found, we highlighted the following as the most relevant for this context. Yin et al. Define AR as a tool that defines overlays as digital content onto the physical world, helping operators see and act with enhanced clarity. Chen et al. Show how this improves real-time interaction, enabling faster, better decisions during complex tasks. As Bozic notes, AR is now seen as the cornerstone of Industry 5, where the goal isn't automation, it's human-machine intelligence. Yet AR remains underused, especially in SMEs. Pesot et al. Links this to cost, integration complexity, and poor usability in fast-paced environments. Finally, Yin et al. Observed that most AR systems aren't designed for the scale and flexibilities small industries need. Applications and advancements. On the left, applications, Christ et al. Showed how real-time overlays during assembly can reduce mistakes and improve accuracy. For the purpose of training and collaboration, both Ho and Reljic et al. Demonstrated the value of immersive tools for improving retention and speeding up prototyping. Transitioning to the right, it's not just about what AR can do, it's about how it's delivered. Web AR eliminates the need for web app installations, making it easier to deploy. Wearables free up the user's hands, helping AR function during live talks without added friction. Current state of AR. Across a range of industries, augmented reality is being used to guide technicians through complex procedures, overlaying live instructions directly onto the machinery and equipment. Simon et al. Demonstrate how this improved task accuracy and reduced reliance on manuals, ultimately enhancing both safety and speed on the shop floor. In assembly lines, Christ et al. Showed how AR-enabled visualization helps align digital designs with real-world execution, leading to fewer errors and faster decision-making. From the cases we've reviewed, these ones stood out as some of the most impactful examples. Airbus cited a 500% increase in assembly speed. Lockheed Martin reported a 30% reduction in fighter jet construction time. Bosch noted a 15% improvement in automotive repair efficiency. These examples suggest that when implemented effectively, AR has the potential not only to improve precision, but also drive meaningful gains in operational performance. AR is still underused. Hussar et al. Showcased AR's success in small part assembly, highlighting increased accuracy and operator support. However, in many SMEs, the brief and repetitive nature of tasks can lead to AR being seen as excessive. Jack Tab et al. Also show how hygiene and usability issues slow uptake in food manufacturing, but some of these limitations may carry over to the other sectors as well. Together, these studies point to a deeper challenge, not the effectiveness of AR itself, but rather the barriers around perception, ease of integration, and contextual suitability within real-world workflows. As Mohammed Hussein et al. Pointed out, the future of AR and SMEs hinges not only on how well it performs, but also on how adaptable, trustworthy, and usable it is in day-to-day operations. Zooming out for a moment, beyond just performance, we see broader challenges starting to surface. When negative perception meets cost pressure, operator fatigue, and poor UX, even the best AR tools can struggle to scale, especially in resource-constrained environments. Pesot et al. Reinforces this, arguing that for SMEs to benefit, adoption needs to be made simpler, built around usable design, trust, and real funding support. Other studies echo this. Nagy and Windhausen both highlight that wearable discomfort, fatigue can lower long-term satisfaction. And Yaktab et al. Reminds us that public trust in AR remains a challenge, particularly in regulated or high-stakes environments. Overcoming the barriers. These challenges won't vanish overnight, but they can be addressed through intentional human-centered design. Mohammed Hussein et al. Emphasizes that adaptive user-informed AR systems are key to sustained engagement. Pesot et al. Adds that public innovation support such as R&D subsidies, tax credit, or subsidized loans can ease financial constraints. And when AR is embedded within broader digital strategies, firms are more likely to attract external investment. And perhaps most importantly, when designed with simplicity and immersion in mind, AR can help close digital skill gaps rather than widen them. Future research. Recent research in AR is moving in promising directions. Kumar al. and Windhausen et al. Focus on reducing cognitive load through improved interface design, while Sayadi et al. Explore XR integrated and adaptive systems. While reviewing a wide range of sources, these studies stood out, especially in showing that AR is well represented in areas like training and predictive maintenance, but its role in unplanned downtime remains less explored. This impression was further supported by Yin et al.'s review of over 100 AR-related studies where they found limited emphasis on real-time fault recovery compared to the other applications. To confirm, we conducted a literature scan across platforms such as Springer, Science Direct, ResearchGate, and Mendeley, using search terms like AR in manufacturing, reactive maintenance, and downtime support. We reviewed recent publications, and as shown in the table, AR appears well represented in areas like human-robot interaction, user experience, and visualization, but studies directly addressing unplanned downtime remain scarce. To explore this gap further, we developed a methodology based on a digital twin. This led us to a case study at the Central University of Technology in Bloemfontein, South Africa, where a small-scale water bottling plant was built for research and integrated with a digital twin. The diagram shown reflects the original setup, which was designed to optimize cycle time using 3 key substations: a flow rate sensor, a water level sensor, and an infrared sensor for bottle counting. In our study, we revisit those same substations, this time injecting simulated sensor faults and errors to observe system response under unplanned downtime conditions. How digital twins work. A digital twin is a virtual representation of a physical system that updates in real time based on live data. Digital twins continuously stream aggregate data from IoT sensors, but they can also draw from historical records, user inputs, and broader system logs. They provide a rich system-wide view via dashboards. However, these layers of processing, aggregation, and visualization can introduce delay, especially when rapid decision-making is needed. In this study, the digital twin serves as our benchmark for comparison. To complement the digital twin, a lightweight AR diagnostic layer is introduced. An external camera feed is used to capture the fault station in real time, while the AR overlay is rendered on the user's device, allowing the setup to remain lightweight. This camera has 2 roles. It provides a live external view of the fault location, and it assists in positioning a preloaded CAD overlay of the internal fault area or the sensors. These overlays are triggered by simple fault data, not streamed, so the system can immediately show what went wrong, where, and why. The goal is not to replace the digital twin, but to enhance its response during disruptive events. This slide compares how digital twins and AR systems respond to the same sensor event. Digital twins.
Excuse me, sir. Sorry to interrupt, but around 9 minutes are over. Can you please wrap up?
No problem, I'm almost done. Digital twins send full data to the cloud where it's processed into formats that tools like MATLAB can interpret. These are then rendered into dashboard instruments that the operator must analyze and interpret. AR, on the other hand, pulls only the necessary inputs directly from the digital twin and sends them to the user's device with minimal processing. This allows it to immediately display what happened, where, and possibly why, offering quicker real-time guidance. Measurement strategy. This table shows how we'll compare both systems across simulated faults like sensitivity, damage risk, or sensor interface. Each condition is injected in MATLAB and monitored externally without relying on subjective feedback. We are measuring 2 key metrics: debugging time, which is how long it takes for a clear, actionable visual cue to appear on the screen, and overall downtime, the average time taken across repeated fault simulations, used here to reflect broader performance under pressure. On the right, you'll see the elements common in industrial dashboards like flow meters and water level gauges. These typically require multiple steps to render and interpret, especially compared to AR overlays, which are preloaded and optimized for speed. Unplanned downtime is hard to predict and costly. Digital twins offer system-wide monitoring, while AR may add faster, more intuitive insights for operators. Together, they can speed up fault detection and response, changing not just the speed, but the experience of how unplanned downtime is handled. I'd like to thank the Central University of Technology for providing access to the facilities and funding for this research, and to the ICTIS Thailand conference organizers for this well-organized platform to share and discuss our work. I am open to receiving questions if there are any.
A very insightful presentation, Mr. Mohoje. I just want to understand that how do you simulate the physics of the physical like flow or other parameters into AR?
So thank you very much for the question, sir. So at the moment, we are currently still in the experimental phase. So as I shown in the slides earlier, we're going to start with a digital twin and simulate some results of how, if I go back to this table here, just simulate some sensitivity. Maybe we'll have the physical experiment to see how the data looks, and then create an algorithm of how sensitivity, how damage risk, and no flow detection, and take it from there.
Yeah, this is the biggest challenge actually. Yes, yes, yes. All the best for the work.
Thank you very much, sir. Thank you very much. Are there any other questions? Okay, thank you.
Thank you for your presentation, sir. Moving on next, I'd like to call Sir for the paper titled Enhancing Quality of Service in IoT-Enabled Wireless Sensor Networks Through Dual Optimization Techniques. Can you please start with your presentation? Sir, are you in the meet? Meanwhile, we can go on to the next presentation. I'd like to call Juhi Patel for the paper titled Harnessing Machine Learning for Soil Microbial Biomass Enhancement and Sustainable Agriculture Solutions. Ma'am, can you please start with your presentation?
Yes, sure, ma'am. Can you please stop sharing your screen? Hello, everyone. Is my screen visible? Hello. Hello.
Yes, please.
Yes, sir.
Please go ahead.
Yeah. Greetings, everyone. I'm Juhi Patel from GLS University. I'm honored to present my research title is that harnessing machine learning for soil microbial biomass enhancement and, and sustainable agriculture solutions under guidance of Dr. Tejas Kumar Bhatt. These are the outlines of my research presentation. Uh, as a soil microbial biomass is the living component of soil organic matter, is like bacteria, fungi, plays a vital role in maintaining the soil health. This microbial supports the nutrient cycling, improves the soil fertility, and contributing to the long-term productivity and ecosystem resilience, which are crucial for the sustainable agricultures. Those are very helpful for the maintaining the soil for better crop yield production. These are the research papers which I have studied for this research. In the first paper, that the random forest model has been used for soil organic carbon and high accuracy. That this is that for future work, integrating the environmental parameters is important for predictions. Another paper has been used the SVM model for the outperform the classical model in soil classifications, and in the future work, they said the SVM to predict a broader range of soil attributes. So by studying these research papers, these are the some research papers I was showing here. I have used the methodology that says that this includes the robust ML pipeline integrating the data pre-processing, feature selections. Then I splitted the data into training for the 80% and testing for the 20%. I have used machine learning models that random forest, SVM, and LR. And after that, I use the performance evaluation. As the shown in the agriculture diagram, we analyze that the data from the diverse sources to build the productive models that inform the agriculture practices and decision making. I have collected data from the many sources that and these are the some data set parameters I have used the bulk density, pH, organic carbon, nitrogen, phosphorus, microbial biomass, NDVI data, the soil moisture, temperature, and precision. Along with that, I have used the three model aggregation assessment, the mean absolute error, root mean square error, and R square. These three helps in accessing the accuracy of model reliability, understanding the which variable is most influence precision allows for the better soil management and strategies. This is the heat map where we use for the correlation analysis, helping us to understand the relationship among the variables and refine our model inputs. Uh, Also, along with that, this is the again the heat map of the numerical representation of the data set parameters and how those are related to each other. And this is the random forest model demonstration to the high accuracy closely following the perfect prediction line, while the SVM shows the greater variance error in indicating the potential improvement and predicting the soil microbiomas. Random forest provides the best fit and closely aligned with the actual biomass values where the SVM says the greater variance error in this. This is the evaluation criteria for the diverse machine learning models. I have used the three model linear regression, random forest, and SVM. So these are the three visual comparison actual values, the showcasing that the accuracy evaluation highlighted by the score of S square is 0.95 0.95%, while the SVM is 0.46 for the I square in the taste purpose. This suggests that the random forest and linear regressions are the more reliable in this domain. While to conclude, the evaluate the machine learning models like LR, random forest, and SVM for predicting the soil microbiomas and address the accuracy of the supporting sustainable farming conserving practices. These random forest and linear regressions are effective in predicting the soil microbiomas that they have providing the 95.1% of biomass accuracy. This supports the sustainable agriculture by adding the informed decisions. While SVM is the not suitable for for this case, in the cross validation used for the extensive model performance evaluation, then in the future, advanced features engineering integrating the larger data sets, exploring the approaches for the investigating assembles methods to combine the model and improve the accuracy, we can use that. And these are the references which I have followed for the this presentation. Is there any query if anyone is having?
Yeah, Juhi, have you tried to correlate this with the actual soil sample?
Sir, actually, I
Or
have
this is only
collected.
based on.
No, sir. Actually, I have collected data from the Anand Agriculture University. So they have provided me the I already collected data. They have collected data. So I have analyzed those data and after that interpreting this result. Anand Agriculture
All
University is
right.
in located in Gujarat. So I have used those data set for this result and parameters.
Yes. Okay. So your data sets are from there. Can you ask them to validate it on their soil samples again? I mean, that is something that would make a very good validation for the results that you are making.
Yes, sure, I'll do that.
Yeah. All right. Thank you.
Thank you, sir. Anyone else is having any questions?
Julie, is there any another test to apply for your data set? Is it possible? Another test?
Uh, I haven't tried that, sir, but I can try with the comparing the more than two parameters. So I can try on that.
Okay. Thank you.
Thank you, sir.
Thank you for your presentation, ma'am.
Thank you, ma'am.
Moving on next, I'd like to call Mr. Vachara, sir, for the paper titled Laser Pigeon Deterrent. So please, can you start with your presentation?
Okay, let me show my screen. Okay, is my screen visible?
Yes, sir.
Okay.
Yes, go ahead.
Okay. Good afternoon, everyone. I am Vachara Viriyakun from King Mongkut Institute of Technology, Lat Krabang, Bangkok, Thailand. I'm honored to present our research titled Laser Pigeon Deterrent. This project is a response to a growing challenge in urban environments, the increasing nuisance and public health concern caused by pigeon infestation. Okay, here's the roadmap of today's talk. We will begin by examining the problem of urban pigeon infestation, followed by a review of related technologies, Then I will highlight the research gap and present our objective. Next, I will walk you through our methodology and include the image processing pipeline, laser targeting mechanism, and remote monitoring system. Then we will look at our experiment results, preview the device prototype, and conclude with key insights and directions for future works. Okay. The urban pigeon infestation are more than just a nuisance. They cause real economic health and environmental issues. Pigeon dropping are acidic, causing erosion of building material, historical structure, and vehicles. These birds also pose a health risk as their waste can spread fungal and bacterial infections through the air. Traditional solutions like spikes, chemical nets are costly to maintain, limited in effectiveness, and may harm other species or the environment. Our aim was to design a human automated and intelligent deterrent that functions in real time and adapts to urban field conditions using laser and machine learning. Okay. Several methods have been proposed to control bird populations like okay. Wait a second. Okay, from the literature review is recent advancement in AI, particularly convolutional neural network, allow us to detect and classify birds in a real time from video input. YOLO is you only look once is especially well suited for real-time object detection due to its speed and accuracy. On the hardware side, Gauss scanner are commonly used in precise laser beam positioning for medical imaging, barcode scanning, and engraving. So I think we need this Gauss scanner to adapt into our work. However, this technology have not yet been integrated into a real-time bird deterrent system that includes both AI-based detection and adaptive laser targeting. Okay, the research gap is there is no existing autonomous deterrent system specially tailored to pigeon and operated in urban outdoor environment. There is a lack of intelligent laser control systems that can make real-time decisions based on object classification, especially when it comes to safety, like distinguishing humans from birds. Okay, next, the methodology overview. Our system use image detection, YOLO version 8, laser targeting using Gauss and digital to analog converter, control board using Raspberry Pi 4 and Coral AI accelerator, and web-based monitoring. And we also integrated Google Coral AI accelerator, which use edge TPU to drastically reduce the latency of neural network interface. For durability, our components are enclosed in waterproof case. I will show you in the section that show our project. For okay, next one, Gauss scanner I will use ILTA 2000K. Laser will use 532 nanometer, 1 watt visible to pigeon. Connectivity with LAN, Wi-Fi, and real-time web-based UI with mobile access. So the important one is image processing. Our system rely on a custom trained YOLO V8 object detection model. We collect and annotate over 1,700 images capturing pigeon in various postures like flying, feeding, and perched. and against urban backdrop like building, park, like this image is park, to ensure model robustness. Okay. We apply grayscale histogram equalization and normalization during pre-processing. Resize all input to 416 times 416 pixels for consistent model input. And use normal maximum suspension to eliminate overlap boxes. Apply multi-frame tracking to reduce false positive. And do dual detection like pigeon and human for safety interrupt. Okay, next one. The targeting by light. Once a pigeon is detected, the bounding box coordinates are converted to XY coordinate and XY position signal using 12-bit digital to analog output to control the Gao mirror adjustment. And we implement two targeting strategy, direct targeting and sweep mode to avoid pigeon habituation. In terms of performance and safety, our system archive response time only 0.403 seconds that from detection to laser activation. The area targeting deviation is around 279 pixels, which is within an acceptable error margin for a deterrent system. Next one is remote monitoring system. Our system can be controlled remotely through a web dashboard developed with WebRTC and Socket IO. This interface allows users to view real-time video feeds, enable or disable the laser, adjust system threshold, and monitoring detection events and system status. Okay, for the result, we evaluate the system across various times of day and urban locations. Here the key is finding pigeon detection accuracy 78.18%. First attempt is 49.09%. Average laser response time is 0.15 seconds. The use of adaptive sweep motion significantly increased success rate over repeat exposures. The system functional reliably under different lighting conditions. True performance dips slightly in very low light due to camera limitation because I use RGB camera. And false positive were minimized through multi-frame tracking and human detection logic. Overall, the system provides fast, accurate, and safe deterrence. Here, this is device showcase. On the left side is 3D model that we use 3D printing to print it. As you can see, this is a camera. This is a Gao scanner with mirror attached. This is the laser side. Okay. For the conclusion, to summarize it, we successfully developed a real-time machine learning powered pigeon deterrent system. The key innovation is we use YOLO version 8 for detection, laser control via Gao sensor with a digital analog converter, remote operation via web dashboard, safe, autonomous, and scalable. As for future work, we plan to integrate infrared camera for the nighttime operation, improve tracking algorithm for high-speed bird motion, enhance Gao scanner calibration for even more precise targeting. For the acknowledgement part, this work was financially supported by KMITL and Bettersoft Company Limited. The others gratefully acknowledge their support in making the research possible. Here it is the reference of this research. Thank you very much for your attention. I now welcome any questions for feedback you may have. Thank you.
Thank you. No questions for me.
Okay, thank you very much.
I have one question.
Okay,
Your accuracy is 78.18, right?
yes, the
Yes,
detection accuracy.
good. Can apply digital signature is your RGB image? Is it possible?
Pardon? Could you say it again?
Okay, can I apply a digital signature to your RGB image? Is it possible?
Yes, it is possible, but we need to adjust something to match your case.
Okay. Thank you.
Thank you. Thank you very much.
Thank you, sir, for your presentation. Moving on next, I'd like to call Mr. Upendra Singh for the paper titled Nuclear Norm Induced Lightweight and Robust Teacher-Student Network to Classify Hyperspectral Scenes. Sir, can you please start with your presentation?
Sure, ma'am. Just give me a moment. I'll share my screen.
Okay.
I hope my screen is visible. Can anybody confirm?
Yes, it is visible.
So, good morning to everybody. This is Upendra Singh presenting before you this work, which is actually related to doing something to a teacher-student network to make it robust and lightweight. This work is actually a result of the work done by my students named Akshay Anand, Akshay Methini, and Patel Hit Manoj Kumar. And this would be the brief outline that we will be covering. We will try to cover the basics of whatever we have done so far. So coming back to the introduction part, so we are basically proposing something new to an already existing teacher-student network. So we know that a teacher-student network is a network where a teacher network is actually a network which has been trained on a bulk of training data and which is performing reasonably well. The downside to this is that teacher networks may not always be deployed on resources which have some computational constraints, right? So in those cases, there was a development of a student network. The idea behind having this student network is let us have a network which is less complex compared to a teacher network, but which is having a performance which is more or less similar to what the teacher network is showing on a large data set. So what essentially involves development of a student network is something called as knowledge distillation, where the information or the knowledge that is there with the teacher is distilled to the student network so that it is able to perform reasonably well. By reasonably well, I'm basically trying to say that my student network should be able to have a performance of generalization that is as close as possible to the teacher's network. Now, the thing is, uh, this is the basic paradigm of a teacher student network. So let us come to what we are trying to do. See, what happens is that when a student network is supposed to be deployed in an environment, the performance of this student network can also get impacted by the noise present in that particular environment. This work is basically trying to ensure that whatever student network we train, that student network remains as much immune to noise in the background as possible. And for this particular purpose, what we have done is to the loss function of the student network, we have added an additional term which is nuclear norm regularization. So in front of your screen, you have got two loss functions, one towards the left hand side and the other towards the right hand side. The loss function mentioned in the left hand side is actually the convection loss function for a student network. This loss function we have modified by adding an additional term, which is a nuclear norm term, as can be seen on the right hand side. This nuclear norm regularization is also weighted by a strength of regularization beta. So what essentially will happen is after this nuclear norm regularization is actually provides mathematical guarantees that whatever parameters this student network will learn, those parameters will remain immune to changes or some noise which could be there in the novelty part is there in this particular network. We have used nuclear norm regularization to ensure that whatever student modules parameters are obtained, they remain as immune as possible to the noise. Now, and this nuclear norm always provides a theoretical guarantees. So coming back to the loss function, we have a soft loss, we have a hard loss. Soft loss is how well the student network has been able to adapt to the teacher network. Hard loss is all about how well my teacher network is doing. So alpha is a scaling parameter which will combine both these losses. And in addition, we'll have this regularization term. Now, this particular teacher student network. So what actually is, if you go back to the title, so it's a nuclear norm induced, which means there is nuclear norm regularization which has been put. And where has it been put? It has been put into a student network, and by default, the student network is lightweight. So I believe that now justifies the title. This proposed student model is then used to for land scene classification. For sake of fair comparison, we have gone for the benchmark datasets available in the domain of remote sensing. Primarily, we have used US Merchant and WPSU RESIC 45, AID, and Eurosat datasets to just run our models and compare the generalization performance. The different characteristics of these datasets are already provided to you in this particular slide. Some little bit of pre-processing was done with regards to these datasets in terms of resizing and normalization. And then they were actually used to train our models. As far as possible, what we have done, we have ensured that the training test split is the conventional training test split for these datasets, so that whatever comparisons we get, they are as fair as possible. So the dataset creators of these datasets, they have suggested some training test splits, and we have followed exactly those training test splits. Now, coming back to the results, the idea was that we should be able to have a student network which is relatively lightweight, and at the same time, it is also robust to changes which could be there in the form of noise, right? And if you go back to the loss function, this beta was the regularization that was controlling how much regularization should be added or what amount of weight should be put to this regularization norm. These are the results that we have obtained for the different data sets. So in each particular graph, we can see there are two different subgraphs or two different things we are trying to show. With orange ink, we are trying to show the performance of our model with nuclear norms in the loss function, and the blue curve is the one that shows the performance of my student network without this nuclear norm. So these results for the different data sets are provided, and for the sake of completeness, all the results are already provided in the paper. Now, what we are able to understand, on the x-axis we have got the regularization strength values, and on the y-axis we are basically showing the performance of our student network. And what the result we are able to say is that in general, the student network which has been trained with nuclear norm regularization, that remains that is showing a better generalization performance compared to the one which is without this nuclear norm regularization. However, we cannot go for a student network which provides unnecessary weightage to the nuclear norm, which means I have to have this regularization, but these weights beta cannot take extreme values, because then the performance might go haywire, because then the more focus of the classifier would be to regularize to obtain low rank solutions as compared to minimizing this soft and hard losses. And this is actually evident also. For example, if you look at the column in the left hand side, in general, the performance with nuclear norm regularization remains higher, but when the regularization strength is increased beyond a point, then what happens is the whole of the energy of the network goes into obtaining the low rank solutions instead of
Hello. What is?
I think we lost the voice connection.
Okay. So, meanwhile, we can go to the next presentation, maybe.
No, just let him. Upen, can you hear us?
Is he on mute, maybe?
Am I audible now? Am I audible now?
Yeah. Yes.
Okay.
Yes.
Sorry, sir, for the interruption.
Yeah, no worries. Upen, I had a question.
Yes, sir.
That is the spectral data that you are using. Is it time sensitive? I mean, does it depends on a time series?
No, sir, it was not a time series data. It was actually a historic data. The only thing we have ensured is that whatever trend test splits the authors of these data sets have provided, we have just followed that part. It remains a historic data. No time series element.
All right. Because otherwise, drift would have been a problem when you
Yes,
apply normalization.
definitely,
Yes.
sir.
Okay. Thank you.
Definitely. Okay.
Thank you.
So I'll just take 30 seconds to conclude. We have basically come up with a modified teacher-student network where the idea is to have a student network that is lightweight and at the same time robust to noise, which could be there in the deployed environment. Thank you. In case there are any questions, I will be happy to answer.
Very good work by your students. Congratulations.
Thank you.
Thank you for the presentation, sir. Hmm. Moving on next, I'd like to call Mr. Vakara sir for the paper title Portable Signboard Size Measurement for Tax Collection. So could you
Okay.
please start with the presentation? Yes.
Okay, I will share my screen. Okay, here we meet again. Hello everyone again, I'm Vachara Riyakun from KMITL, Bangkok, Lat Krabang. Today I'm excited to present our research on a portable sideboard size measurement system for tax collection, developed with the goal of making tax assessments for efficient and accurate in the field. Okay, first slide is agenda. Here the flow of today's presentation. I will begin with introduction to the problem we tackle, then walk through related work in the literature review. Next, we will identify the research gap and present our hypothesis. Next, we identify, then we will explain methodology, include image processing and billboard size calculation. Finally, I will show the result, the conclusion, and open the floor for the questions. Okay, cyber tax is an important municipal revenue stream, but collecting it is labor intensive and error prone. Manual measurement in the field faces three major challenges. The first one is inaccessible locations. The next one is human error, and the last one is time-consuming process. Our objective is to create a portable and automated solution that improves accuracy and reduce workload for tax officers. Okay, for the literature review, the various technologies have been applied to improve cyborg tagging, like GIS and GPS help with location data but not physical measurement. YOLO-based object detection offers high accuracy but hasn't been tailored for this specific use case like for tax collection. And most importantly, past studies haven't addressed the field readiness or integrated sensor-based size estimation. This reveals a clear gap we aim to fill. Okay. The next one is the key gap we identify is the absence of a portable real-time system that can accurately measure sideboards in practical outdoor environments. Our problem statement is how can we automate and simplify the sideboard measurement process for tax collection? So, methodology overview. Our system integrates both hardware and software. Hardware includes Raspberry Pi, Node MCU, LiDAR, GNSS, gyroscope, and Pi camera that used with Raspberry Pi 4. On the software side, we use YOLO V5 because of the efficiency, but the power consumption is smaller than YOLO V8, so we use YOLO V5 for real-time detection and OpenCV for processing and size analysis. All data is filled to convert image coordinate into real-world dimension. Okay, this is a hardware component diagram. We highlight the core components. The Raspberry Pi 4 runs the detection and processing algorithms, while the Node MCU manages sensor data like LiDAR, rangefinder, gyroscope, and GNSS module. And the next one is UPS for the power unit. Next one is sensor integration and processing. We use LiDARs for distance, gyroscope for the angle in X, Y, and Z axis, GNSS module for latitude and longitude, dual processing with Raspberry Pi 4 and Node MCU. Next, sensor data fields for accurate dimension calculation. Okay, this is the sensor integration and processing diagram. So as we can see, the sensor data collection from LiDAR sensor, gyroscope sensor, and GNSS module, pack it to the Node MCU processing that will formatting data, combine sensor data stream to AX, axis X, axis Y, axis Z, latitude, longitude, and distance, and send it to Raspberry Pi 4 via the serial communication. And the next one is Raspberry Pi receive the data to and data tracing and validation, sensor fusion algorithm, and dimension calculation. Okay, the important part is image processing part. Once a sideboard is captured, the system runs YOLO V5 to detect in real time, then enhance the image using grayscale conversion, and a detection. Next is half and candy a detection and half light transform, and we will get the edge of billboard. And we apply tilt correction using gyroscope data to improve accuracy and use OCR or optical character recognition to detect the text on the sideboard to determine language composition for text classification. Because of foreign language, it has expensive than the Thai language when we calculate the text. Okay, the next one is datasets for object detection. Our YOLO V5 model was trained on a carefully built dataset, like start with 2,379 real-world images for sideboard. This dataset I combine from the open dataset from Kaggle and from my image that I take it myself. Next, the augmentation, rotation, and saturation adjustment. I choose this to augmentation because the rotation is when the officer go to the field test or the field, it's possible to rotate the portable sideboard measurement device to capture the billboard. Okay. And the expand dataset to 7,137 images, making the model more robust for real-world conditions. Okay, we done with RoboFlow framework and single class label
Excuse me,
is
sir.
billboard. Okay.
So sorry to interrupt, but around 9 minutes are over. Can you please wrap up?
Okay. And dataset split training 87%, validation 8%, and testing 5%. Okay, billboard size calculation, we use a pinhole camera model and field of view theorem to find the formula to calculate the image size to real size, like this formula. Okay, the result is we test our system on 11 real sideboards with accuracy is around 63%, high is 81%, and area is 60%. But important thing is processing time, only 7 seconds per sideboard, but in the traditional way that we use the tape to measurement, we use the time around 15 minutes or 10 minutes to calculate one sideboard. Okay, this is device showcase. Okay, the conclusion is we develop a portable automate measurement tools and improve speed, accuracy, and reduce manpower needed in field. In the future, we aim to enhance with measurement, improve screen visibility outdoors, and speed up processing for complex science. The acknowledgement is work financially supported by KMITL and CPY Consulting. Okay, this is the reference. And thank you for your attention.
Vachara, where are you running your models?
Pardon?
Is it on the, are your models being run as edge computing or they are being run on the cloud?
The model is running on the Raspberry Pi single board computer.
Okay, so that is capable of handling the kind of processing that you require?
Could you say it again? Sorry.
I'm asking, can the device handle the specific processing requirements that your model is using?
The timing or something?
Would it make any difference if you change the device to a higher processing instead of a Raspberry Pi?
If we change the device or if we change the processing module?
Yeah.
If we change the processing module from Raspberry Pi or something that can calculate speed more than Raspberry Pi, it will reduce the time below the 7 seconds per sideboard. I think so.
Okay, thank you.
Okay.
Thank you so much, sir. Moving on next, I'd like to call P. Sakti Sundaram sir for the paper titled Enhancing Quality of Service in IoT-enabled wireless sensor networks through dual optimization techniques. So can you please start with your presentation?
Yes, ma'am. Good afternoon to all. I am audible.
Yes, sir.
Yeah, screen is visible now, ma'am.
Yes, yes.
Yeah, okay, thank you. Good afternoon to all. Actually, I am P. Shakti Sundaram from Electronics and Communication Engineering Department, College of Engineering and Technology, SRM IST, Katangattur Campus, Chennai. My topic is enhancing quality of service in IoT-enabled wireless sensor network through dual optimization technique. My paper ID is 463. My presentation flow will be introduction, motivation, application of wireless sensor network, challenges in wireless sensor routing protocols, literature survey, problem statement, objective, and references. Introduction. In the wireless sensor network, basically we are forming the cluster formation. In the wireless sensor network, we have majorly 4 parts like cluster and cluster heads and sensor nodes and zinc node. Zinc node is nothing but a receiving node. Actually, here I am taking the IoT enabled wireless sensor network. Here I am using fuzzy logic and neural network, combining these both two. In fuzzy logic, we are having a fuzzylizer and rule-based and interface engine, then defiler, and we are getting the output. The fundamental concept of wireless network is membership. Just a minute, ma'am. Yeah. Wireless sensor network, fuzzy we are using. Then mainly we are going for fuzzy logic system is for membership function, represents the full membership function. Then we are moving to a neural logic system. Actually, a neural logic system, primary function of process is to analyze the raw sensor data collected from the multiple nodes.
Then we are going to combine these two, that fuzzy and neuro. So we can call it as a neuro-fuzzy logic system. The neuro-fuzzy logic system acts as a smart decision-making system, combining fuzzy logic and neural network to process the sensor data. The applications of wireless sensor network is environment monitoring, precision agriculture, and healthcare medical applications, industrial automation and manufacturing, and smart cities. These are all the main applications of wireless sensor network. And what are the challenges in wireless sensor network routing protocol? These are all the major challenges in wireless sensor network routing protocol challenges: energy consumption, latency, packet delivery ratios, and data redundancy, and end-to-end delay and network lifetime. These are all the main challenges in wireless sensor network. The literature review, we are taking Zigro et al. The title, The Comparison-Based Routing Strategy for Energy Saving in Wireless Sensor Network. It gives path latency is 84% and 73%. Then Meenakshi, efficient communication in wireless sensor network using optimized energy efficient latch cluster protocol. Then Gomal et al. Enhancing the title life of wireless sensor network using fuzzy logic least technique based PSO, that is a partial swarm optimization. Here they are achieving a packet transmission by 17.6%. Then Kogan Nipatal, title of intelligent algorithm for energy efficiency optimization in software-defined wireless sensor network for 5G communication. Here they are achieving the energy efficiency like a 40% and 30.95 improvement clusters. Then Chandrasekharan et al. Here the title is energy efficient cluster head using modified fuzzy logic with WOA and path selection using enhancing CSO in IoT-enabled smart agriculture system. Here they are having a packet delivery issues. Then Chitra et al. Published the paper in physical communication. The title of the paper is Delay Optimization and Energy Balancing Algorithm for Improving Network Lifetime in Fixed Wireless Sensor Network. Here they are using maximum data path of megabits per second. Then again one for quality optimization. My objective is enhancing quality of service in IoT-enabled wireless sensor network through dual optimization technique. Optimization technology. Quality of service. In the Internet of Things, enabled wireless sensor network face significant challenges due to the discovered content inherent in sensor resources required of application operating with these networks. The quality of service in IoT-enabled wireless sensor is focusing some of the parameters like data. Already we are saw the challenges like energy consumption, packet delivery ratio. These are all things we are focusing with. Here in the optimization, we are using a two optimization combining and we are achieving the quality of service. We have combined the Akula optimizer, AO, and LibbyPyte optimization to energy efficient for selecting a cluster gate and the cluster gate performed path in the dynamic IoT environment. The fuzzy logic integrated address that is used for energy, and then LibbyPyte we are choosing for a path selection. These are all the performance metrics, energy driving model we are using. These are the formula we are applying for getting the selecting the energy, selecting the cluster gate. And performance matrix, distance between cluster gate and member node. Based on the distance from the sync node and the cluster, we are selecting the cluster gate. This is a basic block diagram for our proposed NFDR, the neuro fuzzy real mechanism. Here we are using the network parameters like cluster gate and base station, cluster gate node, and degree of cluster gate. Here we are giving a energy driven model for both. That's a fuzzy logic generators, and the fuzzy logic is going to using Aqua optimizer and compute parameters, fitness mutations, and update mechanism and cluster formation. That Liva Aquila optimizer is used to select the cluster formation. Then Livy flight optimization, it is used to select the path. So combining these two, we are achieving a neural network and we are going for a optimization by using this. These are the two basic pseudocode for optimal cluster formation and optimal path selection using LF. And these are all the simulation parameter tools we are using. For network size is 300 meter into 300 meter. Number of sensor nodes we are using 150. Number of sensor node we are using 1 sync. And these are all the initial energy we are assuming for the nodes before going to simulate. And here the data packet size is 128 bits and data packet transmission rate is 250 packet per second. And cluster gate we are assuming 5 nanojoule per bit. And these are all the simulation runs we are going up to 1000 or 2000. Here in the simulation result, first we are going to see the packet delivery ratio. Packet delivery ratio performance the proposed approach out from multiple simulation runs, specifically PDR of NFDO method have given average gives the 95% in 500 iteration and 70% in 1000th iteration. 1500 iteration it gives 54 percentages and 2000 iteration it gives 48% of packet delivery ratio. These are all the comparison between other algorithms. This is the packet delivery ratio parameter. Then we are going for packet loss rate. The packet loss rate also is going to be compared with some other algorithms. In the high, like a 2000 iteration, we are getting 0.03 packet loss rate. Compared with other algorithms, the proposed PDR algorithm, NFDO algorithm is giving a 0.03. Then we are going for average end-to-end delay. End-to-end delay is nothing but we are sending a data from one node to another node. Here also we can see the difference between compared with other algorithms. The proposed NFDO algorithm, it will give even though in a high iteration, the 200th iteration, it gives 0.22% of milliseconds. The end-to-end delay is giving. These are the other comparison algorithms. GW means gray wolf optimization. DCRN is deep cognitive reinforcement network, and ERNS is enhanced region navigation satellite. NFC generalized fuzzy clustering. These are the comparing algorithms with NFDO. Then we are coming for latency. It will give the same thing. See here, we are comparing with some other algorithms. The proposed NFDO algorithms gives the in 200 iteration, it will give only 0.15 latency. Then the main thing is throughput. Throughput is one of the major parameter in the wireless sensor network. In the throughput, we are having megabits per second. In 500 iteration, we are getting a 10 megabits per second. In 1000, we are getting 25 megabits per second. And 150, we are getting 40. And 2000, we are getting 50 megabits per second. Then we are going for reliability. Reliability is also one of the major parameter to ensure the network lifetime. Okay, here we can see the comparative algorithms. In the 200th iteration, it gives 42% of reliability in the network. Compared with the other algorithm, our proposed NFDO is giving a good reliability even in 200 iterations. Then we are comparing finally we are going to compare the quality of service probability. In the quality of service, we are having a 51 and 48, 45 and 42% of quality of service probability in 200 iteration. And a summary of our objectives: a newly designed neuro-fuzzy double optimization algorithm. It gives the good quality of service and lowest packet loss rate with the average of 2% compared to 5%, 6%, 7% and some things. And end-to-end duration at the network latency, the proposed NFDO approach is achieving respectively, and the energy efficiency with the average of this. So finally, we can go for a neuro-fuzzy double optimization algorithm. It will give a good quality of service compared with the other algorithms. And these are all my references. Thank you.
Mr. Sakti, I just want to understand why does this algorithm work better? In a layman's, I mean, I understand when you go for some nature-inspired algorithm, there must have been a foundation reason why you chose this specific algorithm.
Yeah, of course. Actually, generally we are going for a single optimization, but in this simulation I am using a neuro-fuzzy. That is one of the major novelty, neuro-fuzzy wireless sensor network. And why I am choosing a two algorithm in the sense, a call algorithm will choose for cluster formation and another lever fight optimization only focusing for path selection. Initially, we are going for only one optimization, but here we are going to combine the two optimization to get a better quality of service for the entire wireless sensor network using IoT.
Okay, so it would work exactly the same for a Internet of Things based network instead of a WSN only. I mean, I could have a complete network of IoT devices and could still be applicable.
Yeah, yes, sir.
All right, thank you.
Thank you, sir.
Sir, I have one question. Is there any validation in your work, research work? Is there any validation?
Any?
Sir, is there any validation in your research work, sir?
No, sir, no, sir, no, sir.
Oh, okay. What are the benefit of the dual optimization technique? You apply this model. What are the benefits?
Yeah, actually, the main benefit of this combined dual optimization is to get a better quality of service by using Nero fuzzy. Actually, generally, we are using a Nero network will be there, fuzzy network will be there. Separately, they are using that. The main novelty is Nero, by combining Nero fuzzy is a novelty, and we are going to check the quality of service by using a dual optimization.
Okay, okay, okay.
To ensure the Nero fuzzy network will be a good quality. That's the thing we are going for this dual optimization.
Okay. Thank you. Thank you.
Thank you.
Thank you so much for the presentation.
Thank you, ma'am. Thank you for having us.
I sincerely thank all our authors for their excellent presentations and contribution in this session and all the previous sessions. I hope the session was informative enough. We, on behalf of the whole team, thank you for your support during this 9th version and all previous 8 versions of this conference. We'll be happy to have you in the 10th version in 2026. All the presenters will be getting their digital certificates through email within 2 working days. And further, all the papers have been already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS 2025. This is a token of appreciation to both the session chairs. On behalf of the team ICTIS 2025 and Global Knowledge Research Foundation and partners,
Thank you
thank you,
so much,
sirs,
Richa.
for your valuable presence. So, before we end, I'll kindly request everyone to switch on your cameras for a quick snapshot. Okay. Thank you, everyone. Have a nice day.